Now we're going to talk about section 2.7. Again, I'm just going to talk about it briefly because we did this handout in class. 2.7 is all about inverse functions. And remember, there were lots of ways that we thought about inverse functions and what an inverse function does. So what I'm going to do is I'm going to use algebra to find the inverse of a function. And so I think I'll do number 7 from our 2.7 handout. So let me write it down for you. Number 7 has the function f of x is equal to 4 over 5x minus 1. There it is. And the instructions are find the inverse of this one-to-one function. Remember, only one-to-one functions have inverses, and if it's not a one-to-one function, we can fix it. So remember, we can fix it if it's not, most of the time. So let's go through the steps. And these are the steps I told you about in class, so get out your notes and write them down. Okay, let's see. First step was take out the f of x and put in y. Y is equal to 4 over 5x minus 1. Okay. The second step was everywhere you see an x, put a y instead. Everywhere you see a y, put an x instead. Remember, that's one of the ways we think about inverse functions. They take your x, y values and they flip them around. They swap the x's and y's. Okay, so every ordered pair is reversed. So x is equal to 4 over 5y minus 1. Alright, now let's just solve for y. Remember, you've done the inverse part here. Now you have to use algebra to solve for y. That's the hard part. So what would I do to solve for y? Well, the first thing I would do is clear my denominator. I would multiply both sides by 5y minus 1. And so what you should get is 5y minus 1 times x is equal to 4. Right? Okay, now, there are two ways to do this. I'm going to show you the way that I think is the most straightforward. Next, I want you to distribute your x. So I can get 5xy minus x is equal to 4. And now remember, the goal is to solve for y. So let's start that sorting process. Everything that has a y, every term that has a y should stay over here on the left-hand side. Every term that does not have a y should be moved to the right-hand side. So we're going to add x to both sides, and we will get 5xy is equal to x plus 4. Now, there's my y. I only have one term, so to isolate y, I just need to divide by 5x. Divide by 5x, so I get y is equal to x plus 4 over 5x. Stop. Don't cancel the x's. Okay? Careful. You have to factor before you cancel. There's nothing to factor in the top. Now the very last step was, this is now the inverse function of the original function that we called f. So to show that, we use the special f inverse notation. I want to remind you, this -1 is a superscript on the f. This is not an exponent. Let me repeat myself. That is not an exponent. It does not mean 1 over f. It means the inverse function of f. Okay, now let's do the one that was a little bit tricky, and that was number 9. So again, I'm looking at the 2.7 handout. I'm looking at number 9, and that function is f of x is equal to the square root of x minus a. Now, the instructions for this just say find the inverse function, but I'm going to do more just so that we can make a point here. And the thing I'm going to do is I'm going to graph this. Now this is good review. We learned how to graph these in section 2.5. So let's scoot over here and make a lovely x, y. There we go. And so remember, f, that's a square root function. So I'm starting with the basic graph of the square root of x. It's shaped like that, right? And our f has been, let's see, moved to the right 8. So 1, 2, 3, 4, 5, 6, 7, 8, say here. And then I would have another point here. So it would look something like this, right? That's what f would look like. Let's put that there. Y equals f of x. Okay, now for fun, let's write what the domain and range of this function are. Domain and range. And I'm going to use the graph to figure out what the domain and range are. So look at the graph again. Remember, the domain is the set of all x's that get used or can be used in this function. And I don't start until 8, and then I go forever and ever, ever. So that is 8 to infinity. So I would use interval notation and write that. The range is the set of all y's. Now, the y's start here at 0. There's no y below here, no point below there. And then they'll continue to go up slowly because it keeps rising. So that's 0 to infinity. The range is 0 to infinity. Okay, this is going to matter in a minute. Now, what I'm going to do is I'm going to leave space up here to write down f inverse when we figure out what it is. And then I'm going to go below here and do the algebra. Okay, so let's move over here to do the algebra. Some scratch paper. Remember, step 1 is take out the f of x and put in y. So y is equal to the square root of x minus 8. Okay, now, to get rid of the square root, I'm going to square both sides. So you should get y squared is equal to x minus 8. Oh, what did I forget to do, guys? I guess I could do it now, huh? Remember, you're supposed to swap your x and y. Everywhere you see an x, you put a y. Everywhere you see a y, you put an x. Silly me. Alright, let's do that now. So I would get x squared is equal to y minus 8. Okay, notice you can do it at any point along the way, but you should really do it first. Alright, now, remember the goal is to solve for y. So let's add 8 to both sides. And I get x squared plus 8 is equal to y. Or, let's write that in f inverse notation back up here. F inverse of x is equal to x squared plus 8. Now, I want you to be really, really careful. Remember, we talked about the fact that inverse functions, the x and y values get switched. So that means the domain and range get switched. What do I mean by that? The domain of f inverse should be the same as the range of f. So that means I automatically know that the domain of f inverse is from 0 to infinity. And I also automatically know that the range of f inverse is from 8 to infinity. Now the 8 to infinity I understand completely, because when I look at f inverse, because of what we learned in section 2.5, we know that that is a parabola that's been shifted up 8 places. Okay? That's a parabola that's been shifted up 8. However, the domain does not match what a domain for a parabola is. Domain for a parabola is all real numbers, because there are no problem x's. I could put anything I wanted in there. But it wouldn't be the inverse function if I did that. Okay, let's look at our graph again. So let's go up here to 8. 1, 2, 3, 4, 5, 6, 7, 8. So I'm supposed to be graphing a parabola, but if it tells me the domain is 0 to infinity, that means I'm only graphing the half of the parabola that starts here and goes up. That's it. Now double check that that is correct, because the other thing we learned was that the graphs of inverse functions are symmetric through the y equals x line, right? So if you look at that tilted, see that mirror images. If I put the other branch of the parabola here, that wouldn't work because its mirror image would not appear over here. Alright? Now, how should I write that down over here besides just listing the domain? What we do usually is write, comma, x is greater than or equal to 0. Remember, that's called restricting the domain. And because we need to do that, because f inverse, if I had both parts of the parabola here, is not a one-to-one function, and it has to be. It has to be a one-to-one function. So the way we fix it is we just use the part we like and throw a part away with the part we don't like. And that is 2.7.